Hello, Algebra. So what we're going to talk about today is it's about solving equations and how we can extend that into other parts of algebra. So we'll just start with a simple equation to solve. So what if we had 2x equals 6? All right, well, we need to solve for x, right? We'll solve for x. So how do we solve for x? Well, what it means to solve for x is that we have x equals something at the end. So to get to that, let's go over here by the x. We have a multiply by 2. So to get rid of the 2, we'll divide by 2. And I'll cancel, divide by 2, and we get x equals 6 divided by 2. 6 divided by 2 is 3. So x equals 3. All right, so we are used to doing things like that. However, sometimes we might not have numbers. Okay, so those are the kinds of situations we're going to look at. So what if instead of a 2 we had bx equals, instead of 6 we had c? Well, to solve this for x, we would do the same exact thing. So right now we have a b times our x. So to get rid of that b, we'll divide by b on both sides. These b's will cancel and we'll be left with x equals c divided by b. We don't know what c or b are, alright? So this would end up being our answer. X equals c over b. Alright, so let's see, how can I extend this? This is my first time using this program. I can just erase it. Alright, so now what if I have, oh, please erase. This is not a very good eraser. Okay, there we go. Alright, so let's look at another equation, but maybe a 2-step instead of a 1-step. So what if I have 2x minus 1 equals 5? How do I solve this? Well, first I get rid of the minus 1. The opposite of minus is plus. And then we'll add 1, because negative 1 plus 1 is 0. So that cancels. Add 1 to the other side. So now I have 2x equals 5 plus 1 is 6. Alright, next step. Still trying to solve for x, we need to undo the multiplication of 2. We divide both sides by 2. We get x equals 6 divided by 2 is 3. So we're solving for x, so we end up with x equals something. Now, what if with just letters we have bx minus a equals c? Well, we're going to do the same thing first. We have the subtraction, so we're going to undo that by adding. So now those a's cancel, and I have bx equals, we don't know what c or a are, so we just have c plus a. Alright, we're still solving for x. We need x by itself. So we'll do b times x. Well, that means we have to divide by b, and we do it on both sides. Those will cancel, and we're left with x equals, we don't know what b is again, so really x just equals c plus a, all that divided by b. Okay, so we're doing the same steps, we just can't simplify like we would with numbers. Alright, let's do another one. What if we have, oh my goodness. Erase quicker. Sorry guys, this takes a while. Not the most user-friendly program for videos right now. Okay. So what if we are solving for x still, right? It'll tell us which one we're solving for. What if we have x over 7 equals 2? These kind of problems tend to be an issue for us, but what we have is x divided by 7. How do we undo division? We multiply. We multiply this entire side by 7. We only do that so that these cancel. So we're not doing 7 times x at all. Okay? because what we're really doing is we're doing 7 times x over 7. Well, that's 7 over 1 times x over 7. And then we have 7x over 7, and that can reduce by dividing by 7 and getting x over 1, which is x. Okay, so that's what we're doing in that whole step of just multiplying the whole thing by 7 and then canceling out. Because if we were to do all that, we would end up reducing and just getting x. But then we multiply this side by 7, so we have x equals 2 times 7 is 14. So we solved for x. Now, you might have something with variables that looks like x divided by y equals z. All right, we're still solving for x. How do we get rid of the y over here? Well, it's being divided, so we'll multiply by y on both sides. Y's will cancel, and we're left with x on this side. And then we have z times y, which is, we can just write as zy or yz, same thing, okay? So we solve for x. We have x equals something. All right, so you're probably wondering why the heck do I even care? I mean, what's the point? So the reason we're talking about this is when we are talking about linear equations, so far we've talked about equations in standard form, right? So that's ax plus by equals c. All right, there's another form called, I, for some reason, am forgetting it. Oh, duh. Sorry. Slope-intercept form. So in this form, we can easily find our slope. It's super easy to just point out in there because it's given. And then we can also find our y-intercept super easily. It's literally right in front of us. But in order for slope-intercept form, what we have is y equals, and then everything else. All right? So what we have to do is, to get something in slope-intercept form, is to solve for y. So if we have 2x plus 4y equals 16, so that's in standard form. Now if we want to get it in slope-intercept form, we solve for y. So first what we'll get rid of is stuff that is totally like not touching the y, away from the y, and that's this 2x. So to get to the 2x to the other side of the equal sign, I will subtract 2x from positive 2x. 2x minus 2x is 0. So those will cancel, and I have minus 2x over here. So now I have 4y equals, I'm going to write this as negative 2x plus 16, and I'll talk about y in just a second. All right, now we just have this y and this, well, 4y, right? So to get rid of the 4, we have to divide by 4, and that'll cancel, and we're left with y. All right, now we have to divide this entire side, yes, the entire side, by 4. All right, so when we do this, what we're doing is we're doing negative 2x divided by 4 plus 16 divided by 4. We can split it up if we have division or subtraction here. Split it up like that. All right, so negative 2x over 4, that would reduce to negative 1 over 2 times x. We have a number up on the top. We can write it out after the fraction as well. So our x written up here is the same as just having this fraction multiplied by x. And negative 2 over 4 reduces to negative 1 over 2. All right, plus 16 over 4, that's 16 divided by 4, which is 4. All right, so this is our slope-intercept form. All right, so what is so nice about slope-intercept form is that right here, the number in front of x, that is m. So when we solve for y, we get mx plus b. We get it in this form. M is slope. Right, we've talked about that. M is slope. Okay. B is our y-intercept. So if we wanted to graph this, we would find our y-intercept, which right here it's plus a positive 4. So our y-intercept is 4, or the point 0, 4. And then we finish by using our slope of negative 1/2 to graph that function. So the purpose of this video, though, is to get used to solving for a single variable and moving around letters and numbers. So there should be a worksheet today for you to practice solving for specific variables, and then I just wanted to show you what slope-intercept form of a linear equation was to show you the motivation behind this.